Are you struggling to learn Kubernetes? You're not alone. In this video, we dive deep into the most common mistakes beginners make when learning Kubernetes and how to avoid them. Whether you're a developer, DevOps engineer, or just getting started with container orchestration, this guide will save you hours of confusion and frustration. 1. Skipping the basics of containers and Docker. Why it's a problem. Kubernetes orchestrates containers, but if you don't understand how containers work, you'll be lost when dealing with pods, images, and networking issues. What to do? Learn Docker CLI, Docker build, Docker run, Docker PS, Docker exec, etc. Understand concepts like Docker file structure, image layering and caching, volumes and bind mounts, container networking basics. Tip: try building and running a simple Node.js or Python app in a Docker container before introducing Kubernetes. 2. Trying to learn everything at once. Why it's a problem. Kubernetes has hundreds of APIs and tools. New learners often jump into Helm, operators, CRDs, GitOps, and service meshes too soon, leading to burnout. What to do? Start small. Focus on mastering pods, deployments, services, ConfigMaps, secrets, and basic troubleshooting. Use incremental learning. Phase 1, core concepts. Phase 2, storage, RBAC, scaling. Phase 3, Helm, CI/CD, GitOps. Phase 4, advanced topics like operators and custom resources. Tip: don't worry about mastering everything. Start by getting one app to run well in a cluster. 3. Ignoring YAML structure and formatting. Why it's a problem. Kubernetes configurations are written in YAML. Misplaced indents, tabs instead of spaces, or invalid keys can result in cryptic errors. What to do? Use a YAML-aware editor like VS Code with Kubernetes plugins. Validate manifests using kubectl apply fyourfile.yaml dry run equals client. kubectl explain deployment. Follow conventions like anchoring common config values to avoid duplication. Tip: try using Customize or Helm to template your YAML as your setup grows. 4. Not understanding how Kubernetes networking works. Why it's a problem. You might assume that containers just magically talk to each other. But understanding service discovery, DNS, ingress, and network policies is critical for debugging. What to do? Learn how. Pods communicate within a node and across nodes. Services expose pods internally or externally. Ingress controllers manage HTTPS traffic. Tools to explore. kubectl port forward. kubectl exec plus curl or ping to test network paths. Tip: experiment by deploying multiple pods like Nginx and a node app and having them call each other. 5. Hardcoding configuration in manifests. Why it's a problem. When you hardcode environment variables, secrets, or settings in your deployment YAML, it's hard to maintain and unsafe for sensitive data. What to do? Use ConfigMaps for non-sensitive configuration. Use secrets for passwords, tokens, and certificates. Reference them in your pod's environment or volume mounts. Tip: use kubectl create config map or kubectl create secret to manage these objects programmatically. 6. Not monitoring or logging your workloads. Why it's a problem. When an app crashes or misbehaves, you won't know why without logs or metrics. What to do? Start with kubectl logs. kubectl describe pod name. Add observability tools. Prometheus plus Grafana for metrics. ELK, Elasticsearch, Logstash, Kibana, or Loki for logs. Consider managed solutions, Datadog, CloudWatch, etc. Tip: practice debugging a failing pod using kubectl logs, describe, and exec. 7. Neglecting RBAC and security best practices. Why it's a problem. Running pods as root or giving services cluster-wide access opens up major vulnerabilities. What to do? Learn RBAC basics, roles, role bindings, cluster roles. Always follow least privilege. Don't give services or users more permissions than necessary. Avoid mounting service account tokens unless required. Use security contexts. Security context. Run as non-root, true. Read-only root file system, true. Tip: tools like OPA Gatekeeper or Caverno can enforce security policies automatically. 8. Using Minikube or Kind without understanding the differences. Why it's a problem. Each local development tool has pros and cons. Choosing the wrong one might lead to frustration or wrong assumptions. What to do? Minikube, great for local feature-rich Kubernetes simulation. Kind Kubernetes YAML Docker lightweight, good for CI/CD pipelines and multi-node setups. K3s or Micro K8s, lightweight Kubernetes distributions for edge and testing. Tip, use Kind for scripting and CI pipelines, Minikube for GUI and learning. 9. Forgetting to clean up resources. Why it's a problem. Leftover services, PVCs, and pods can eat up memory, storage, and clutter your cluster. What to do? Use kubectl get all. kubectl delete deployment. Name. kubectl delete all pods. Automate cleanup with namespaces. kubectl delete namespace dev. Tip. Try spinning up test workloads in isolated namespaces and deleting the whole namespace afterward. 10. Underestimating the value of hands-on practice. Why it's a problem. Reading docs alone doesn't translate into understanding. Kubernetes is deeply experiential. You need to do it to learn it. What to do? Practice with real deployments. Deploy a WordPress/MySQL app. Set up Nginx reverse proxy. Try autoscaling based on CPU. Use playgrounds. Katacoda Kubernetes scenarios. Play with Kubernetes. Local clusters with Minikube or Kind. Tip. Break things on purpose. Delete pods. Scale deployments. Modify configs. To learn how Kubernetes recovers. Like the video? Subscribe for more DevOps, cloud, and Kubernetes content. Drop a comment below. Which mistake did you make when learning Kubernetes?